Alright guys, so welcome to today's video, and in today's video I would like to create a OP room cut move. So basically you create your room and every object within the room is able to be cut through, okay? So you can cut objects in half. That's basically a short description of what this move is going to do. And yeah, so I have this OP room right here, which I've created in private some time ago. So I'm just gonna put this as a model inside of the description, so make sure to check it out. I'm not gonna blend in any video in how I've created this, because I think that it should be obvious in today's times. Back then in 2016, 2015 it was not obvious, but today basically everyone's able to create this kind of OP room right here. Okay, so it is nothing special anymore. Okay, let's start with this thing by right-clicking on the starter pack, then head to insert object, and then create a local script, okay? No, not a local script, I mean create a tool, I'm sorry. Create a tool, and then create a local script inside of there. Let's call this one OP. Yeah, just OP. Make sure that requires handler right here is false, and then go inside of this local script. And let's do the following. So I'm still curious about whether the OP room should start or should come out once you equip the tool, or once you have equipped the tool and press the left mouse button. I think that I'm gonna make this room appear once you have equipped the tool. So script parent refers to the tool, so script is this local script, dot parent is this one, so the local script's parent is OP, which is this tool right here. Script parent and then equipped is an event of this tool, which is being triggered when the tool has been equipped, as the name suggests, okay? Now, next thing we have to create is a remote event inside of this local script, and a script inside of that local script right here, okay? I'm not gonna give them any names because I can, okay? So I'm just gonna refer to them as their default names are, so script remote event and script.script. So script.remote event fire server. So we are going to fire server this remote event right here, which is going to cause a reaction instead of this server script, and that reaction is of course the creation of the room. So create room as an argument inside of this fire server right here. Now we can do the exact opposite of this, which is of course when tool has been unequipped. And if the tool has been unequipped, then we want the room to disappear. Means we are going to fire server this remote event right here again, but this time with delete room. Now let's head inside of this server script and let's refer to the remote event. So script parent remote event, script parent remote event, and then let's do on server event and connect function. There we go. So on server event basically does the following. It is there to react to those fire servers which has been sent out right here, and it can receive certain arguments. So for example, we have arguments right here called create room and delete room, which are the first arguments, I'm sorry. But the first argument of this on server event is always the player. Okay, so the player is automatically being passed via fire server. You do not have to add the player inside of here or anything. It is automatically being passed, as I've said. Now the second argument right here becomes the first one of those. And the first one, or the first ones right here, they fulfill the purpose of telling the script what to do. Therefore, I'm going to call them what. Okay, so if what is to create room, then we want to create the room, alright? So in order to create the room, we want to make sure that there is no room existing currently. So if player character, wait, let's add a not in front. So you're referring to the character of our player, and we want to see if there is something in there called OP room. Okay, so this check might not make any sense as for now, because you guys do not know about my plan. So my plan is to once this OP room is created, to put it inside of the player's character. That's the reason why I'm adding this check right here. And if there is a OP room inside of the player's character, then we cannot proceed right here, okay? Because the task is to create a room, but there is already a room created when this check right here fails. That's the reason why. So, next thing we want to do, so if there is no room, OP room inside of the player's character, we want to create one. Basically by taking this OP room right here and then moving it inside of the replicated storage. So that's the first thing. Second thing is that we have to refer to that. So replicated storage, wait for child, OP room, there we go. And now clone this thing and put it inside of the player's character as I've already told you. So player character. Now make sure that the C frame right here, wait, let's do it up here. Make sure that the C frame of this object, so of the OP room, equals the player character's humanoid root part C frame. Humanoid root part C frame. So C frame is basically the position of the room, okay? So we are setting the room's position equal to our humanoid root parts position, so our root parts position basically. Now when we take a look inside of view here, make sure that, where is it? Yeah, make sure that anchored is true and that calculate is false. That's important. And now let's play the game and let's see how this looks like for now. Alright, as you can see, we're now inside of our room. That's good. So next thing we want to create is a part. Okay, so this might sound a little bit interesting to you. So why are you creating another part when you already have the room? So are we just gonna have the room right here? So why, or what is the purpose of this part? All right, so I'm gonna call this one origin part, and this one is going to be important because we want to tell later on where the origin of our room is, so where the room has originated from, okay? And this is interesting to us because, wait, I'm gonna demonstrate this later on. Let me just quickly write this down. So player character humanoid root part C frame. All right, so make sure that this origin part right here has also has also the same C frame as our OP part right here. So this is basically the origin part of our OP room. And this is important to us, so this part right here. So make sure that it is anchored and make sure that calculate is false. I'm not gonna turn it to transparent, so to invisible right now because I want to show you what the purpose of this part is. So when we equip this OP, okay, and we pretend that this room is already extended, okay, then we have one certain problem. So we are able to move inside of that room freely, okay? Means we are able to operate inside of that room whatsoever, alright? So the problem is, have you ever seen Trafalgar Law operating outside of his room? Probably not, alright? And that is because Oda, so the mangaka, isn't that dumb to do that, okay? But apparently, as we are right here in Roblox, we can do that, okay? And that's a problem I'm trying to point out. So you're able to walk outside of your room and you're able to operate from outside your room, okay? Because your room still exists when you walk outside of it. And that's basically where this origin part right here fulfills its purpose. So we want to check the distance in between the origin part and the player, and if that distance is greater than the distance to the border of this room, so origin part and border, then we want to dissolve this room. And that's basically the whole purpose of this origin part. It is just there to prevent those funny glitches right here. Well, it is basically not even a glitch, it is just illogical, let's say, okay? All right. Yeah, there's also an alternative solution for this problem, which is to make your player unable to run, walk, and jump. I don't know if this solution seems good to me, so I used to do that back then, but I'm now gonna do this solution which I've just presented to you earlier. All right. So let's continue. What we want to do now is that we want to make sure that this part right here is transparent. So transparency 1. Next thing which we're going to do is that we are going to create a tween, which is going to expand the room. So tween service. I have already mentioned the purpose of the tween service and how to use it in many of my videos. So if you're still curious about this, then go ahead and check out some videos from my channel. Why did I just receive those tools? Why did I just receive them? All right. Yeah, maybe let's change this to 10. Yo, I think that it is because this room right here is an instance of my character. And when this room touches a tool, the tool thinks that this right here is actually a body part of mine, so does the room. And therefore it puts it inside of my inventory, alright? So thinks that it is the same as me walking like this towards the arrow as when I expand the room and, you know, touch the arrow by doing so. Okay, so interesting. So the tool cannot differentiate in between those two cases. Okay. Well, that was off topic. Let's get back to our scripting right here. So we're now able to, you know, expand the room. Let's quickly create those other cases in which we're able to dissolve the room. So let's easily continue with our other what. So delete room, which happens when you unequip the tool. And what we have to do right here is that we want to use this check right here, but this time we want to remove the not because we want the OP room to be inside of our character because that's a requirement, you know. But that's the first thing. Second thing is that we want to make a tween play when this is the case. And in this tween, let me actually put this inside of a variable. So replace X with our OP room. Wait. So the goal of the tween has to be to increase the transparency until the whole room is transparent or invisible. Make this tween play. And we want to check when this, or once this tween has been completed, because then we want to destroy the room and we want to destroy the origin part as well. There we go. So let's check this out. Let's see how this looks like. Let's keep our tab right here open to see what happens. Oh, wait. The room has been already deleted because we have accidentally picked up that roca fruit. Yeah, funny thing. As you can see, OP right here, origin part right here. When I now unequip this thing, it still exists. No, it does not exist because it is now being removed. Okay, wait, let go of it again. Okay, interesting. Interesting thing. So I would like to decrease this time to 1 second. So within 1 second, everything right here dissolves. And that's it for this case. We still have to script the case when our player walks out of the room. So, and for that, I'm gonna use something which is considered as bad practice. I'm sorry. Sorry for those experienced scripters out here who are going to blame me for this. So you can go ahead and make your own video if you're here to play me. Alright. Make your own video, come rich, whatsoever. I don't care. So I'm gonna wrap this loop inside of a spawn function. Wait, the loop. Loop is this loop right here is dangerous. So I'm gonna wrap this loop right here inside of a spawn function. What this does is that basically everything inside of here is running in the background. And this loop right here, it loops as long as the origin point exists or can be found inside of the character, which equals does exist, okay? So as long as it exists, we want to compare the distance from our player to the origin part. So if, and then I'm gonna open up those brackets, player, character, humanoid, root part, position, minus, x2, position, dot magnitude is greater or even equals x size x divided by 2, then dissolve room, and then we have to do this. Okay, so let's check this out. Let's see if this works, and if it works, I'm going to explain it to you, and then we can finally move on with the core topic of this video. So we are now expanding right here. I'm not going to walk outside of the room. Dissolve room. Failed because instance is null. Attempt to index null with destroy. Wait. 23 is this one. Now let's call this T2. 26. Failed because instance is null. Look, the funny thing about this is that there is no reason for this to be null because we're not destroying the part or anything, you know? So the part is being destroyed down here and not right here. So why is it still complaining about this? So we can try to make a different approach. So we can take this check, this requirement, we can turn it around. So if the size right here is greater than the distance, no, as long as the size right here is greater as the distance, we just want to continue the loop, okay? So we just want to... Or never mind this while loop, so repeat. Wait until... And let's turn this around again, I'm sorry. But I'm still like experimenting around myself. So let's check this out, let's see if this makes any difference. At least I hope so. So it is expanding right here. And now when I walk outside, it is dissolved. Perfect, perfect, perfect. So I've tried a different approach and it worked. Okay, so the room dissolves, that's good. Let me explain what I've done. So we have this code right here running in the background, okay? And what happens right here is that basically repeats the code right here, which is a single wait. So okay, so the script or this task, so this task right here waits until this happens. This requirement right here is met. So what is this requirement? Let me go through this. So player character humanoid root part position minus x2 position. So what happens right here? We are calculating the difference in between our character's position and the origin part's position. And the magnitude converts this into studs, as far as I've understood it. And we are comparing this difference, and we are checking if the difference in between those positions is greater than the size of our OP room, but only on the x-axis divided by 2. So let me explain you why divided by 2, and let me explain you why only the x-axis. So in this case, I think we could have also took the z-axis, I think. Yeah, so x and z are the same, so we could have took the z-axis as well. Okay, so this does not make any difference, but divided by 2, because 128, I'm sorry, 128 describes this size right here. So if you're able to see my cursor, so describes this size. Okay, so from here to here. But we only want to see, or we only want to use the size or the length of our origin part, or the distance of our origin part to the border. So 128 divided by 2 basically tells you where the border is, starting from the origin part right here. So you have your origin part, and if you move 128 divided by 2 into this direction, then you'll reach the border. Okay, so as you can see, the distance was greater than 128 divided by 2, therefore the room has dissolved. That's basically where this idea has originated from, alright? So, we are now finally able to continue with our core topic right here, okay? So, the topic we wanted to deal with. Alright, so I forgot where I left off. I just went AFK, I'm sorry for that. So what we're now going to do is we're now going to, deal with what I've just said earlier. So in order to do that, we want to do the following. So we want to make use of the spawn function right here once again. This time, we want to loop through the workspace. So get descendants. So that's important. You have to do get descendants. And I'm going to explain you later on why. And right here, you have to write parts, okay? That's important. Part or union operation. Either one of those. So, let me explain you why. So, first of all, why get descendants and what we are doing now. So, we're now looping through the workspace right here. So, and get descendants makes you loop through everything right here. So, not only everything which is superficially visible to you, but also everything inside of here, everything inside of here, everything inside of here, and the same goes for all of the other folders right here. All right, that's the reason why we are doing this. And we want to check if the instance we're currently at is either a part or a union operation, and I'm going to explain you why. So part and union operation, they both share the advantage, or they allow us to do what we have to do in order to cut those parts, in order to create that cut illusion, so that what you guys experience as a cut of any object inside of a OP room can be done, or can only be done on parts and union operations. So you cannot do them on mesh parts, for example. Or have you ever seen a mesh tree being cut? Because I did not, and I could be wrong at this topic, but the method I'm now going to use only works with those two instances. All right. Okay. So next thing we want to check is whether those parts are inside of our room, and we can check that by comparing the positions right here. So basically we just have to take this one and we have to change player character root port position to v dot position, and v is basically the object, so the instance we're currently at. So because we're looping, you know, basically we're comparing both distances, and then we compare the difference to, you know, the OP room's size on the x-axis divided by 2. And this check verifies whether the object is inside of the room. And if that is the case, then we can do what we want to do. And that is to create a click detector inside of every instance right here. And yeah, so we are going to do everything else afterwards. I just want to set everything up to test. So let me move to spawn right here because the tools and all of the other stuff is going to interrupt us. So let me add some things which look like stones or other stuff, you know, so which look somehow interesting to you and which could be used to, you know, cut through all of that. So make sure that those ports are anchored. And yeah, make sure that this is anchored as well. Let's check this out. But before we actually... No, never mind. Let's check this out. Let's check this out. Okay, wait. Huh. Click detector. Breakable wall. All of these ports have click detectors, right? Yeah, they have. And that is because we have to turn this around. So if the difference in between those distances is not greater than that size, then we want those click detector things to happen. Now, another problem is that we are not able to click on those click detectors. Yeah, and that is because we have the tool right here equipped. Okay, no, it is not. Look, the problem is... Okay, wait, those ports are right here, okay? Wait. Wait, so let's take this part for example. Okay, look. This does not seem to work. I'm gonna pause the video. I'm gonna be back when I found the solution. Okay, look, I found the solution. So you guys might understand what is happening when you take a look at right here. So what I've done is that I've printed out the distance and the size, and the size is always the same. Okay, so the size does now really change. Wait, does it change? Okay, it does not. Wait, it does change. Okay, look. No, it does not. All right, look, but the size is at 7.37 whatsoever, although the size has to be at 60. Okay, and this leads to the conclusion that this right here runs directly, so it basically runs in an instant. Okay, and that's the problem, because when the room is still about to expand, and we have this thing running, and we have this as this, then it is totally normal that this is not going to be greater than this, you know? As you can see, we have 20, 19, 26, 20, you know? So all of these numbers, and what we have to do in order to be able to, you know, get this thing to work is that we have to refer to this tween as a variable. So the tween which is responsible to, you know, expand this thing, and we have to check whether this has been completed. So when a tween has been completed and the expansion of the room has been completed, then we can tell, or then we can move on with this task right here, okay? And there we go. There we go. Now, next problem is that we are not able to click on those. So, look, I now might be able to click on them, but I'm not when I have the tool equipped, and that's the next thing. That's the next obstacle, guys. That is the next obstacle. So so we somehow have to get through this. So what we could possibly do is that instead of using this to create the room, is that, well, we could wait. We could do it this way. So instead of deleting the room once it has been unequipped, we can delete it when, you know, when you re-equip and you have a room open. So if workspace, wait for child game players, local player name, find first child OP room, then else. And there we go. So what happens right here is that we are referring to an instance which is inside of the workspace and which has the same name as our player. And this instance right here is of course our character. And apart from that, we are looking for an instance inside of that character, inside of our character, which is called OP room. So this line right here basically checks if there is a OP room inside of your character, which means that you have your OP room equipped. And if that is the case, then we want to delete the room. And if this right here is not the case, so this is every other case besides this, and since this is only true or false, this is the case when there is no OP room inside of your character, then we want to create the room. And this whole thing, this whole process happens once you re-equip. All right, so this makes us able to unequip the tool, but still have the room, the ability, you know. That's the advantage I'm trying to use right here. As you can see, we are able to click on them and then it says cut, but when I re-equip, the room disappears. And when I re-equip again, the room comes back. And when I walk outside of the room, it dissolves as well. At least it was supposed to do so. It still tends to do funny stuff. I don't know why. Okay, so let's continue right here. Wait. Yeah, right here. So we have now inserted that click detector, which detects when you have clicked on it. And this click detector is inside of each parts right here, which are classified as cuttable. Okay. So what we have to do now is that we have to cut those objects in half. So how do we do that? This is basically the part which is the most difficult in my opinion. So you guys might have seen my first giveaway video, which was a wall breaker combat video, in which I've demonstrated to you how to, cut out objects or cut out shapes from other objects, and we are going to use the same method on this one. So when it comes to cut out the half, you have to determine where you are going to cut. So of course for us humans it is pretty easy to tell, because you, for example, see this lock right here, this wooden lock, okay? So let me insert a part, make it really red right here, and let's pretend that this marks the areas you want to cut out, okay? So we as humans, we can easily tell that we are going to cut out everything which is inside of here, alright? Now a computer cannot do that. What a computer would possibly try to do is that it would try to cut out like this, for example, or like this, or whatsoever, So it would do the funniest stuff. And we could, of course, keep it as it is, because for this example, it would not make that much of a difference. Well, it might does, because having your lock right like this or like this is a huge difference in my opinion. But we could try to randomize this process. But the issue with this is being emphasized, in my opinion, with this example. So you see this grass right here, okay? So this is just the flat part, and in my opinion, the best way to cut this in half would be like this, okay? So, but the script could also do it like this. So, so this area right here is still there, but the height was just halved, Or the script could possibly do something like this as well. Okay, and that's the problem I'm trying to point out, okay? So we could either randomize this, or we could really check for the side. So the axis, so X, Y, Z, which has the biggest number in, in size. So for this example, it would be the Z-axis. So it means you would cut from the Z-axis right here. For this one, it would still be the Z-axis, means you would, cut this way. And for this one, it would be the Y-axis, so you would cut right here. But let me point out another problem. So what happens when we turn this, okay? And when the Z-axis suddenly is on this side, because a few moments ago it was orientated like this, but now it is orientated like this, and that's another problem as well. So you guys see, this is harder than most of the people think, and therefore I'm gonna randomize this process right here, okay? Just to keep this video short. So we are almost at 40 minutes right here. All right. So what we can do is that we can set up a random number. Rn stands for random number. We're going to use math random. So we are receiving a random number from 1 to 3, and each number represents one of the axes. So x-axis, y-axis, z-axis. And if Rn is 1, then we want to cut the x-axis in half. If Rn is 2, then we want to cut the y-axis, and if Rn is 3, then the z-axis. Okay, so you guys get what I'm trying to do. At least I hope so. And we want to cut, you know, the z-axis. So the process is going to be the same, so cutting process. We are just going to have different variables according to which axis you're currently trying to cut out. Or we could wait. We could even do it like this. So axis randomizer. Okay, wait. No. I don't think that this is going to work. So I was about to set up a table with all of the axes, so x, y, z, and then just refer to the desired axis via indexing. But I don't think that this is going to work out. So let's just set up a function. But even that won't work out, you know. This is actually so difficult. So let's just move on. So let's create a part. And this part is right here is going to cut out this 1/2. So part workspace, and the size is going to be the size, so the size of our object. But yeah, wait. Vector 3 new v size x divided by 2, v size y, and then some additional numbers. Let's use 100, and maybe not 100, but let's use 5, and v size z also plus 5. You might ask why those additional numbers. I'm gonna answer to this later. Make sure that it is anchored, and make sure that can collide is false. All right. That is going to be the first thing. Second thing is about the C-frame of this. So let's, for now, make those C-frames equal each other. Now let's see how this is going to look like. Okay, so it has decided to cut the z-axis. Okay. A C-frame dot new. What happens when we do it like this? Did it work? Did it work? Probably not. Nah, it did not work as expected. Okay, we have to quarter this. Yeah, by quartering this works. Okay, that's good, that's good. Now take this and then put a plus 0.1 to it, because you've seen that the areas they were glitched into each other. So in order to prevent that, yeah, now it fits in perfectly, as you can see. Very good, very good. And the reason why we have now expanded all other axes by 5 is because you guys were able to see it. Okay, so those areas, so of the tree, so of the lock and of this part, they were bugged into each other. And by expanding all of the other axes, oh, maybe not by 5, but by 1, 2, or even 0.1, you will prevent that from happen. Also, I had the idea to rotate this part a little, you know, so that we actually get some variation inside of here, but I don't know if I'm going to do that, because this will just make things more complicated. So I've quickly looked up how I've done this in this breakable combat right here. It seems pretty obvious to me. So all we have to do right here is we have to refer to V and subtract async, and then set up a table, and then put Q inside of here. And wait, part X position, since position, okay. Cut port, parent, workspace. Also make sure that the former part becomes transparent. Okay. So we have now cut out one half, okay? Still have to cut out the other half, but we're going to do that soon. Okay, wait, so you're not able to see this? Okay, no. It hasn't been done, it hasn't been done. My god, of course it hasn't been done, because... Oh, yo. Subtract async is not a valid member of workspace part. Subtract async, oh my. I think Roblox had a typo in there. Subtract async. Okay, look, where's the other part? Union? Okay, it is right here. Wait. 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 Okay, so I was experimenting around, and of course this does not work, because we did not really pay attention to one certain thing, which is the C frame right here. So C frame new V size watered, no, V size X quartered a plus, let's do 0.1 0 0, and let's put a minus right here, because this goes into one direction right here, and then for the other part we have to do the opposite. So you guys might not understand what I'm trying to point out right here, but you will once we create the other half. Wait, now everything has totally disappeared, but why? Okay, where is this now? Wait, why did this become invisible now? Oh, because Yeah, very obvious, because we have made this invisible for cutting out. As you can see, we have now created one half, okay? So what we could do is that we could repeat this step in order to create the other half, or we could just take this existing half and then clone it and then move it, you know? So I think that this is way easier to do. So cut part 2 is cut part clone, and cut part 2 dot C-frame equals cut part 2 current C-frame multiplied with this, just without all of those minuses, and plus 0.2, because you have to imagine this already makes this thing move to the left, and then this minus 0.1 makes it move a little bit more to the left, but we have to compensate this one, and we have to add a additional 0.1 to it because we want to move this thing a little bit more to the right. You know, that's the reason why we put 0.2 right here. And what we also have to do is that we have to make this Q right here transparent, because this has been bothering me. Okay, so if everything goes right, we should have a tiny spot right here. Okay, we do not. Wait, why is this transparent? So we have... No, we only have one union. Yeah, but why? So do we have to parent this or what? So I'm parent this to the workspace. Now we have created multiple ones. For some reason this didn't really turn out as expected. But why? Is it because of this? Let me try to do it this way then. So 0.2 is not enough or what? Should we add 0.2 right here as well? Wait, so there are so many questions currently inside of my head. What happens when I put 0.5 right here? What happens when I increase this? Look, so the relation of it changes a little. At least I think so. What happens when I put a 1 right here? Okay, so this was it. I don't know why, but apparently adding a 1 has helped. I have no idea why, but it seems to have helped. So we were able to divide this now. There we go. So, but this is only for the x-axis, you know, so we still have to do the same for the y and the z-axis, but that's not a problem because we have now done this for the x-axis, and the rest is just about, you know, wait. Yeah, the rest is just about changing this up. So let's do +5 divided by 2. Take this. Okay, let's try this out. Let's see how this looks like. Okay. Wait. So what I surely have to do is that I have to delete this click detector later on. Yeah, and I have to make this recursive. That's another topic. Let me copy this. Let me put it right here. So I hope that you guys get what we are trying to do right here. And that is to... wait. To create the stuff for all of the other axes. So now for the z-axis, for example. But we still have to test this out, and we still have to see if this actually works as expected. So after this was done, we have to destroy the click detector. Okay. As you can see, this was just sliced up. So how was this sliced up? I can't tell. I can't tell right now. Probably like this. Well, what about this? Yeah, okay, yeah. Okay, yeah, so that's one problem I was fearing. So look, let's change this to 1, okay? The problem is that we used those numbers right here to make, you know, to make things move either to or more to the left or more to the right. Now, those numbers only work with this size, so with the size of this lock, so with the lock's x size currently. We have to find decimal numbers, percentages, which allow us to do the same thing. So, let me give you an example, or let me try to find it myself. So as you can see, we have +1 right here, for example. We have to change all of this, so +1 minus 0.1, no, 0.1, 0.1, and 1, so we have to change them to decimal numbers somehow. And we have to find out how. Okay, let me actually pause this and let me come back when I found them out. Alright, so let me give you some examples. So instead of having 0.1 right here, you have to take the size of the object and multiply it with a certain number, with a certain percentage. In this case, 1%. So 1% of the x size of our object is additionally being added onto this one. The same goes right here, and the same goes right here. So make sure to use this instead of those decimal numbers, such as 0.1 or other numbers. Okay, because this step right here makes this distance right here adapt to each object. Otherwise, you only have decimal numbers which are only adapted to one certain object, so to one certain size, to, you know, and that's the problem, guys. So that's a fix for it. So you have to do it this way. Instead of having 0.1 right here, just add this. Instead of having minus 0.1, just add this. Instead of having 1, just do this. So 0.35, you know. And the same goes for this one. So now let's change this to math random 1, 2, 3. Let's see if this works. I hope that this works. If not, then we have a huge problem. But I think that this is going to work. So no worries about this. 1. No, it did not work. Oh my god. It is because I probably have to find out a new percentage for this one. Wait, no. Wait. No, it does work. No, it does not. Wait. I'm so confused currently. Wait. Look. This did work. This did not, for example. Instead of having it like this, let's actually spice things up by making those numbers a lot higher, a lot more greater right here. Okay, look. So we have now successfully cut out those parts, okay? We have now destroyed this click detector. What we could do is that we put this inside of a function. Cut part. Make this a local function. And what this requires, wait. Call this cut part F. Cut part F requires V. And yeah, what is it going to do? That's a question. Also, we have to create, so for my idea, we have to create 2 other click detectors inside of each cut part right here. Oh wait, we can actually do it this way. So now things get a little bit complicated for you probably, but I hope that I'm still able to make things understandable for you. Look. Local cut pot. Local cut pot 2. So we now have those two variables which are empty by the beginning, but which receive a value, I mean a reference, depending on which if statement becomes true. And at the end, when those cut parts appear, we want to create a click detector inside of both of them. And this click detector is going to run this function. And yeah. Cut port, wait. Is it cut port? Yeah. So the problem with this is, so this function right here becomes recursive, means you're calling a function inside of itself. And this is some kind of loop, okay? And we have to break out of this loop. So the cool thing about having this as a recursive function is that you're now able to cut those parts down. So like this, for example, as you can see. Wait, okay, it did not work out as expected. But as you can see, I can make several cuts on this one. Wait, the problem is that yeah, okay. Okay, well, look. We now have two problems. First problem is that the distance in between both parts is still not that great. Oh, and that is because, oh my god, oh my god, oh my god. Oh my god, that is because we still use the axe size. That's the reason why. Oh my god. And I was wondering about why this is now working out as expected. Look, then let's change everything back, because those numbers were actually fine. I was just angry about, or disappointed about, that it did not work out, you know? That's the reason why I've changed those numbers, but apparently it did not work because I was still using the axe size. Wait, so after 2 cuts, you're not able to do anything on them. Whatever reason. Look, I'm not able to cut them anymore. Oh, wait, I am. Yeah, interesting thing. Look, so why am I not able to cut them, for example? Yeah, so this is, of course, a little glitchy. Well, it is, but it is not at the same time. I cannot really understand the nature of this. Although I have created this myself. Look, what a funny thing. So, why am I not able to click on this? Come on. Does it have some kind of cooldown? Oh, look. Biggest problem about this is that you have to destroy V after you have used it for your things. So make sure to destroy V afterwards, because otherwise you'll have this problem. Wait, let's try this out now. So, yo, we are able to cut this infinitely. Look. We are able to cut this infinitely if we want to. Look, look, look. Yo, let me... Am I able to cut the base plate? That would be a cool thing. Oh, probably not. There we go. Look, look, look. We are cutting this down. Yo. Now it works. Now it works. Okay, look, there we go. So, we're probably even able to... No, we're not. I was about to say we are also... Or we could also be able to put out dummies. The problem is that those consist of mesh parts. So if you have any R6 model, then this could... Or this might work. But I don't know about mesh parts. I don't think that this will work with mesh parts. Okay, guys, look. Now, 2 more things we have to do, and then we're basically done. First thing is that I would like to add a particle, or a billboard GUI, or I don't know how you call these things. So some kind of effect, a slash effect, every time when you cut something. That's the first thing. Second thing I would like to add is that that those parts, they levitate inside of the room. That's it. After those parts, we are going to end the video immediately. So first thing is that I'm gonna look out for a slash decal. I'm sorry for that. Well, I proudly preach that I'm a self-made hustler whatsoever, a Roblox hustler who always does things by himself. But I have to disappoint you today by using someone else's slash right here. It could be, wait, let me pause the video. It could be that I have a slash thing myself, a slash image. I have one, I have found one. So I can't remember if I have made this by myself or whether it was one of my developers. Not really sure, but it was at least made by someone who I know, okay? Either myself or a developer of mine. There we go. Okay, there we go. Okay, so let's go inside of here. And every time when this function is being called, we wanna clone this GUI right here. So game get service, replicated storage, wait for child, cut. So we want to clone this, and we want to put this inside of V, and we want to change the rotation of this before. So probably inside of here, yeah. So cut GUI, image label, rotation, math random from 1 to 180. Something around that. Let's see if this works. I forgot to make the to destroy it afterwards. Okay, it did not work. Didn't work. Why? Why didn't it work? Oh, because V is being destroyed. Because V is being destroyed. Yeah, look. Look. Then we have to do it this way. Game debris add item V after 1 second. Now let's destroy this then. Yeah. Let's play. Let's see how this is going to look like now. There we go. At least this works now. Okay, yeah. They cut it by yeah. Okay, look. Next thing we are going to do now is that we are going to make this semi-recursive. Means we are going to add a limit of cuts you can place. Otherwise, you'd be able to infinitely cut, you know, and I don't want this to happen. So next thing we want to add is another variable called n, and n describes the amount of cut sessions you've been through. So when you initially trigger this function, it is of course 1. But right here where it gets recursive, you want to do n plus 1. So n plus 1. Okay. And yeah, up here, want to check if n is greater than 5, for example, and if that's the case, then you want to return. Okay, so you're only able to place 5 cuts, or 5 cuts or 5 cut sessions, and after that, you're not able to do this anymore. 3, 4, and 5, and now I shouldn't be able to cut anymore. Okay, I'm still am. No, I'm not. Okay. I'm not even able to count properly. Wait. No, I'm still able to cut. Wait. Oh, wait. I'm not able to cut for this particular part. Okay, look. This makes things even better. So you're only able to cut on one certain part 5 times. Okay, I'm not able to cut anymore. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. I'm not able to cut anymore. 1, no, 2, 3, 4, 5. Why isn't it cutting? Wait, it might be that the script is bugged. Oh, we could wait. We could do it like this, because return tends to bug the script a little. So we can wrap this inside of this check. There we go. Okay, now what we can do, or what we should do now, is that we should make these levitate. Before we do that, no, we just want to make them levitate now. So we want to add a body position instance.new body position inside of each cut part. And yeah, so make the position be their current position plus vector new math random and also make sure that the parts are anchored false and that can collide is false as well. That's very important, and I've now only done this for one part. I'm going to do that for the other parts as well. So for a second cut part, no worry. And now it fell through because it did not really adjust the max force. So max force vector 3 new. Instead of adding math.huge, I want to try out something new, because we don't want this thing to be too forcefully, but it should keep the object at its place, you know. And that's the problem, because I think that we have to make it forcefully. So there is no other way, I think. Math huge, math huge, math huge. There we go. As you can see, it is now levitating. Okay, look. So let's add some kind of cool effect to this by first of all randomizing all of the other axes right here as well. Apart from that, by adding a tween. Wait, just take this one. Local TCP. Okay. BP. Position. BP position plus vector new ref random 1 to 5. There we go. Now, only problem is that are we able to repeat count? Math huge. Reverses true. Delay time, no, there shouldn't be any delay time. Increase this to 4. Let's see what happens. Okay, as you can see, this block right here is levitating now. So they're now levitating. Problem is that we still have to do this for our second cut part as well, otherwise things will look a little bit funny. Okay, let's increase this to 10 because they are moving way too fast. And let's duplicate this for our cut part 2. And then we are pretty much done with this video. And then if you guys want to, I can show you how to use them to fire them at players or something else in the next episode, guys. And I hope that you guys want to see it because I think that this is quite interesting. So OP moves, they are quite interesting in my opinion. Okay, let's check this out. Let's hope that this works. Okay, yeah, so this is actually cool because those things, they are levitating. Yeah, look at this, guys, look at this. It looks beautiful. Okay, yeah. So of course this model is still incomplete, but we are going to complete it, hopefully, if you guys want to see it. And with that being said, thank you guys for watching. Leave a like, subscribe, share this video to all of your friends, leave me feedback in the comment section, guys. Take care and see you in the next video.